In this video, we will use Excel to conduct a right tail test on the population mean. This is for cases when we claim the population mean will be at least a certain level or more. The null hypothesis will be where mu will be less than or equal to a certain level. On the other hand, the alternative hypothesis will be in the form that mu is bigger than a certain constant. We whether form a belief or make an educated guess for the unknown population parameters and call it hypothesis. Then we collect evidence to check whether the data is supporting or nullifying our hypothesis. This process is called hypothesis testing. Note that hypothesis testing on population mean is based on the sampling distribution of sample mean. In order to implement the test, we need sample mean to be distributed normally. If underlying population is distributed normally, then we are good to go. If not, then by central limit theorem, sample mean is approximately normal as long as we have at least 30 observations in the sample. In this video, we will talk about right tail test. We will work with 2004 North Carolina birth data. We have 998 observations, 13 variables. Our research hypothesis is that the average weight of a newborn is greater than 7 pounds. This is our alternative hypothesis, and our null hypothesis will complement this. This is a typical right tail test. Now, there are a couple of statistics needed to be calculated for formal hypothesis testing procedures. One of them is the degrees of freedom, and it is calculated as n-1, n is being the number of observations. Another statistics is called t-statistics. And what we do, we take the sample mean and find out the null value. In a right tail test, even though there is inequality in the null hypothesis, we take the equal sign and pretend that 7 is our null value, and we'll look at the distance between the sample mean and the null value and divide by the standard error of the sample mean. Pretty much we standardize the distance to find the position of the observed sample mean away from the hypothetical value. I will say if that test statistics is very close to 0, that is good news with the null hypothesis, because what we claim and what we have is in line. On the other hand, if test statistics is bigger than 1.9 or 1.96, then the distance will be sizable. Under the null, it cannot happen by chance. Side note, if we are conducting a right tail test, and for some reason, if the sample mean we have is less than the hypothetical value, as a result, test statistics will be a negative number. Then automatically, we will not be able to reject a null because everything is in line with the hypothetical value. So there is no way for you to reject a null if sample mean is less than the hypothetical value in a right tail test. Now, the last statistics is the p-value. P-value is pretty much, if the null is true, we try to find out what are the likelihood of observing a sample mean as such, 7.10, when the null is true. This probability measure will be our key statistics for making a decision about our null hypothesis. Remember, our sample has a mean of x bar 7.10 pounds. And p-value is capturing the probability of having a sample mean above 7.10 under the null. If the null is true, what is the likelihood that we will get a sample mean higher than 7.10? Visually, we can show it on a distribution. If this is the distribution of sample mean under the null, this is going to be 7. If the null is true, again, we don't know, like we pretend it is true, and we have a sample, I have a sample with a mean of 7.10. So I am interested in this area. This area is our p-value. It is good to know what we are capturing, and then we can look at the technical part. Alternatively, we can convert this, standardize it pretty much. What we do, we subtract 7, which is the assumed level, and divide by the standard error, and then it will give you this test statistics. Imagine I will bring it in here. This is going to be 2.0921, and under the null, this is going to be 0. And we are interested in this area. Pretty much the same. So how can we calculate this p-value? There are two options in Excel. One option is with t.dist function. With true, we get the cumulative distribution. So this part will give you this area, and by subtracting from 1, we get this shaded area. Given that we have this test statistics and that many degrees of freedom, we get this as our p-value. And in our Excel version, we have a specific function for the right-tailed test, t.dist.rt, and in the parentheses, we just enter test statistics and the degrees of freedom. We get the identical number. The important part is the interpretation of the p-value finding. Just know that the p-value is calculated under the assumption that the null is true. In a one-tailed test, we always take the equal part of the null hypothesis as our null value. In this example, it is 7 pounds. So, under the assumption that the mean birth weight of a newborn is 7 pounds, if we pretend it is true, then there is only 1.83% chance that the sample mean will be 7.1 pounds or more. Remember, that was our sample mean. This is very unlikely. The probability is very low. But is this small enough to reject the null? As a decision rule, we should compare the p-value with the level of significance. Also, we call it alpha value. Before making any decision on the null, this is the thing we need to do. Now you may know, now ask, what does the alpha value capture? When you conduct hypothesis testing with p-value, you should always compare p-value with the significance level alpha before making a decision. Please note that the level of significance gives us the allowed probability of committing type 1 error, which happens when we reject a null when in fact it is true. 5% is a conventional level of significance used by practitioners and researchers. We are okay to make type 1 error 5% of the time, and now with the p-value we have the observed probability of committing type 1 error. This is way less than the allowed probability, which is a good thing. Now, since the likelihood is very low, then we can confidently reject the null hypothesis. In other words, the sample data supports our claim that the average birth weight is above 7 points. In this video, we conducted a right-tailed hypothesis testing on population mean, and by using p-value, we rejected the null at 5% significance level because our p-value is less than 0.05. Thanks for listening.